Hi guys, it's Miss Reister. I'm going to take you through the lesson boiling and melting points today. And there's also a notebook activity that is included with this lesson, and it needs to be put in your science notebook. So I'm going to walk you through that as well. And I'll try to do it as painlessly as possible. All right, so before we jump into the procedure for getting the graph done, let's take a quick look at the lesson and make sure that we have a good understanding of what it looks like to get all of this data together and why we would even do that. So the importance of observation. Observations are essential to scientists because they help them obtain results. Analyzing data is an important type of observation. Many times scientists will observe data and try to spot patterns. Patterns can be observed among the various groups of elements on the periodic table. So our goal today is using charts and graphs to record scientific data. And we've got 3 guiding questions that we do need to answer along the way, so don't forget about those in your science notebook. What are boiling and melting points? How do boiling and melting points relate to the structure of the periodic table? And what are the features of a successful graph? All right, so now jumping into the explore part of the lesson. Before starting any exploration, it's important to review the key terms and concepts you already know. Take a look at the key concepts. So you have several things here that you can go through, remembering what a group or family is, boiling point, what that definition is. Remember, that was a guiding question, so you need that. What's a melting point? You need that as well for that guiding question. Here we're talking about why we use data and graphs, so that's to try to find a pattern. That is important as well. And I think that's all of those important points that we need. Going here, again, it's just talking about knowing that water freezes and ice melts at 0 degrees Celsius or 32 degrees Fahrenheit. But do you know the melting point of specific elements like carbon? Or how about oxygen? Wait, oxygen melts? Do we know it has a melting point? So in this exploration, you will compare boiling and melting points of different elements to see if trends for these properties emerge within the periodic table. And there are some important Word documents that you need to print out. There is a data table here. It looks like this. We're going to be graphing the melting points of all these elements along with the boiling points of all these elements. You also have graph paper, so you will want to print this out. I do encourage you to hand draw your graph. So I think it's much easier with all the data that we have to plot to just go ahead and do that by hand rather than try to do it on the computer. And then you have a periodic table document. If you need that, I don't suggest you print that out. If you don't already have one, I've told you before, the one I like better is ptable.com. It's colored already, so it's a little more helpful. All right, so when you're creating a graph, one of the hardest things about this specific assignment and this activity is the range of data that we have. So I know that some of you guys have struggled with setting up graphs in some of our labs before. So it is a really important part of science, and it's important you know how to do that so we can see these patterns among the data. So being able to create a graph is an important skill, and here are some of the features that you'll need. You've got to create your axis, right? So your x-axis and y-axis, and you have to know what to put on those and why they go where they do. In this case, in this activity, we're going to use the vertical, that's the y-axis, and label that temperature. Notice that we are measuring in Kelvin, so make sure that your graph is set up in Kelvin. And then this says that increments are set up at 100 degrees. And that's actually not a good range that's going to work for us, because if you happen to look closely at this document, you can see that the numbers are well over 100. We have one that goes up to 5,100, so 2740, 2628. There's a lot of numbers that are over 100 there. And then our horizontal axis, a little easier. We're just going 1 through 20 with the atomic number, because if you look back at that document again, we are just graphing the first 20 elements. So this is the element's atomic number. So that x-axis is a little easier. And then your plot points are basically where those lines intersect. So pretty easy to do there. And then we'll be connecting those as well. So this procedure I've broken out step by step on a PowerPoint because you can tell it's very, very detailed. And a lot of students get really frustrated trying to do this and just really get overwhelmed and give up. But if you take it step by step, it is really not as difficult as you might think. So jumping back in, here's that procedure. Here's the data table that we're using. That graph paper again. So here it says to draw your set of axes where you want to go ahead and get those labeled. They're only going to be positive values, so we're only going to show one quadrant. You're going to label the y-axis temperature and show the unit of measurement in Kelvin. And then you'll label the x-axis atomic number. You'll make those tick marks on each axis and label those with the appropriate numerical values. So in doing that, this is what it looks like. So your your vertical axis, the y-axis is temperature. And our temperature range is huge. Remember, we just looked at that document. And so our graph is going to need to insert these things called a data break. And you put that on the y-axis, and you'll see where I did that in just a minute. So wherever our numbers take a big break, that way it allows us to get all the way up to 5,500 or 5,500 and down all the way to 0 at the bottom. We're able to use this break. And then easily, I said again, going across 1 through 20 for the atomic number. So that part's very easy. All right, so you want to make those tick marks. Here is what that's going to look like. So again, you've got to really take a look at your data here and see, what's the smallest number we see here? And you may not be able to spot it really fast, but it's this 0.95. So that's almost 0, right? It's like very close to 1. So it needs to be at the very bottom. But then we have that 5,100, 5,100. And that's the largest number. So we've got to set up this range to include all of those numbers. So we want to start at 0. And then I went 20, 40, 60, 80. Okay, and it's a little bit off here because typing on these and getting them to line up perfect, it didn't do well. So remember, don't take screenshots from my graph. There are a couple little error things in there that I will notice on somebody else's if they use my material, but this is to help you set yours up. So we have a 0 to 100 range, and then we put this data break in, right? And then we started going up 500, 1,000, 1,500. So this probably actually should have been up here. But in increments of 500 all the way up to 5,500. And so you can see that we have 0 to 5,500. And then over here again, just 1 through 20, very easy. All right, so that's step 1. It's asking us from there that we're going to create 2 plot lines on this graph. We're going to do boiling points and melting points. So we're going to use a red colored pencil to graph those boiling points. And to do that, we're going to make a solid red circle for each data point. And so when we've plotted all that data, we're going to go back and connect those. So if we go on to the next slide, this gives you an idea of what it looks like, but I'm going to show you how to get started on that. So I'm going to try to make this as small as possible so it'll fit on the screen over here. And so basically you're going to start with element 1, hydrogen. So we're graphing it, and the boiling point, remember we're doing boiling points in red, is 20.28. So it's going to be right above really the 20 mark. Okay, so that covers element number 1. Element 2 is helium, and it's 4.216. So we go down over here, and you can see if this is 10, Then this is, 0 to 10 here. So about right in the middle. Okay, that covers element 2. Element 3 is lithium, which is 1,590. So you can see element 3 is right here. And you just continue. Element 4, beryllium. That beryllium is 3,243. So it's way up here. And you'll just continue graphing and plotting all of the boiling points first. So once you've done all 20, that's when you would go through and just use a ruler and connect all of those lines. So then it's asking you to do the same thing for the melting points. You're going to use a blue colored pencil here, and instead of a red dot, you're going to use a blue circle. So when you finished, you should have 2 plot lines. So same set of axes, but 2 plot lines. So we're going to take a look at what that will look like. Again, you can see the blue circles there. So if I put this page back up, we start with hydrogen again, and it's 14.0. So element 1, you can see that blue circle is right in the middle of 10 and 20. And then we go down to 0.95, so that's down at the bottom for helium, element 2. For lithium, we're almost to 500 at 453, so you can see our blue circles there. And then beryllium, element 4, is 1551. So element 4, you can see that's kind of right in the middle of 1500 and 2000. And so you just continue on graphing down the column until you get all 20 of those elements graphed. And then you'll connect those lines as well with a blue line. So pretty easy so far. From there, it's telling us now we're doing kind of something else with these numbers. This is where we're going to be looking for patterns. It says use a black colored pencil and draw a square around the data points that represent both boiling and melting points for helium and neon. So those atomic numbers are elements 2 and 10. Okay, so if we go to element 2, we have the boiling and melting point. And we go to element 10, we have the boiling and melting point. So what can we notice about those that are different or the same from other elements? They're very close together, right? If we look at element 3, these are further apart. 4, those are further apart. Element 5, they're pretty close together, but 6, they're far apart. So that's one trend. We notice they are very close together. And that is element 2, helium, and then neon, element 10. Okay, so that was step 4. Then our next step says to use a green colored pencil and circle the data points that represent the boiling and melting points for lithium, sodium, and potassium. So it asks you to first use a green to just circle, right? So we have lithium, element 3, circle, circle. Element 11, and I went ahead and added the element name under each number just to help me make sure I stayed on the correct element. So then we went on to element 11, which is sodium, Na. You circled that one, and then 19. Circled that point, circled that point. Then it says from there you connect the green circled data points for the boiling point with a green line, right? So we connected all of those. And then we connected the melting points, 1, 2, 3. So that is how we got where we are so far. Okay, so we're starting to kind of see trends and element names. All right, so now it gives you some questions to go through. And from there, you're able to look at the line plot and describe how the boiling and melting point vary with respect to the atomic number. So we're going to go through and answer those. Looking at question 1 to describe how they vary. So temperatures go up and down over the range of the atomic numbers. They vary significantly. So it's saying in general, look at the whole graph. Do we see a pattern? Not really. Like the whole graph, elements 1 through 20, they're all over the place. They're up, they're down, so they vary significantly. Question 2 says, now look at the segment of the graph between the two data points marked with black squares. Okay, so we're looking here between these. It says, describe how the boiling points and melting point plots behave between these 2 points and be as specific as possible. So what do we notice? That the black squares are really close together, right? So it says around helium with the atomic number of 2, and then you've got the Ne neon number 10. The boiling and melting points are very close together, and that's what we observed earlier. Those are very close together. There were a couple more that were very close together. 16 and 17, those were close together too, but we really only had to look at the ones with the black squares. So the boiling and melting points were very close. That's question 2. Question 3, it says, on your graph, the data points between the black squares are data for elements with atomic numbers 3 through 9. Locate these elements on your periodic table. What term or description would you use to identify these elements with respect to the periodic table? So if we look at elements 3 through 9, here we go. 3 through 9. And we notice, what do we notice here? Element 3, 4, 5, 6, 7, 8, 9. They're all in the same what? If you remember, they're all in the same period 2. And they are of many different types. They go to form the alkaline earth metals, to nonmetals, to halogens. So they're all in the same period, but they're all very different elements. Okay, they're metals, nonmetals, and gases. All right, so if we go into question 4, it says, look at the green lines you created by connecting the boiling points and the melting points. So we're looking at this specifically, where we did those green lines. It says, for each of these lines, describe any trends that you see. All right, so if we look at the boiling points, we can see that they're pretty close together, right? We see a trend there for these 3 elements. 1590, 1165, and 1047 Kelvin. They are lower the higher the atomic number, but they're all within the same range. All right, so they kind of trend downwards. Not a lot. They're very close together. But the higher the atomic number, the actual melting point drops. Just a little, but it's lower. So that's what we see on number 4. On number 5, it says locate the elements that we circled in green, looking specifically. What term or description would you use to identify these elements with respect to the periodic table? So we're looking at helium, neon, are we looking at helium? What is this one? Sodium and potassium. All right, so if we go to our periodic table, we can see that they're right here. Helium, sodium, potassium, they're all in group 1 on the periodic table. So if we go back, they're all group 1 elements. It's on the very far right side. The highest boiling point for lithium and the lowest is for potassium. So lithium, and then you can see potassium. They kind of do the same thing. They drop as the atomic number gets higher. All right, so going on to the last question, after reviewing your answers for questions 2 and 4 above, would you define boiling point and melting point as a periodic table family trend, vertical group, or would it be a period trend going across the horizontal rows, or neither? So it's asking specifically, would we see, went the wrong way, hang on. Do we see a trend this way? Or did we see a trend this way? Okay, so let's go back to that question. See, where did we see a biggest trend here? As you go from the left to the right on the periodic table, the boiling points fluctuate wildly from very high to very low. So if you look at boiling points, they're here, here, way up here, way down here. They fluctuate. That happens up and down across the table. However, within the same group or family, the boiling point are close together, but they decrease as you go down the table within the same family. Okay, so they're going to have a trend, a family trend. All right, so I know that can be a very tricky thing to graph. If you have questions on the questions or questions on the graph, please reach out, but don't forget to put that in your science notebook, and have a wonderful day.